Good morning. Today is myself, Rajeshkumar, Assistant Professor, Department of Computer Science, AJ College of Art and Science. Now I'm going to take the subject Internet of Things. In this thing, we're going to see the following topics like an introduction about IoT, definition and characteristics of IoT, physical design of IoT, then logical design of IoTs, and then IoT enabled technologies. And finally, we're going to see the IoT levels and deployment templates. In this introduction, the Internet of Things describe the network of physical objects. That means the things that are embedded with the sensor, software, and other technologies for the purpose of connecting and exchanging the data with over the device and systems over the internet. Then there is an Internet of Things is referred to some of different way, like to rapidly growing a network of connecting objects that are able to collect and exchange the data in real time using embedded sensors. Nowadays, we are using a lot of IoT devices in our day-to-day regular lives. The world's first IoT device was invented in the early 1980s. Then our mobile device, which contained GPS tracking. Then these all then adaptive brightness, automatic brightness changes, then voice detection, face detection, like on a fingertips, a finger thing will be detected. All those will be found out by using these type of sensors. That all comes under the IoT devices things. So the IoT device is basically connecting with like any device, anybody, anywhere. We can connect it with our any business, any network at any time of things. The term IoT of Internet of Things is referred to collective the network connecting devices and the technology that facilitate communicating between the devices and the cloud as well as between the device themselves. So a lot of various activities will be doing through the IoT devices. That means that the data will be collected with the various sensors. After that, we are storing the data into the cloud, and then we can able to take an analysis also. This will all done without any human interaction in between of the thing. That will be all comes under the IoT devices. This increasingly IoT applications are using in AI and the machine learning to add intelligence to the devices. So automatically the machine can take a decision and then based on the activities of the surroundings. Then we have various places we are using the IoT devices. Some of places like every industries, then healthcare centers, hospitals, industrial automation, smart homes, building, automotive and wearable technologies. So these and all are comes under the IoT definitions in this thing. Now we're going to see the characteristics of IoT. IoT is a dynamic global network infrastructure of physical and virtual objects having a unique identities which are embedded with software, sensors, actuators, electronic and network connectivity to facilitate intelligent application by collecting and exchanging the data. IoT has 10 major features and they are scalable, connectivity, artificial intelligence, security, dynamic nature, endpoint management, integration, analyzing and compact nature of devices. So we can using IoT in various places. So connecting everyday things, day-to-day life, we are using various electronic devices. A major thing is like our Bluetooth headset, then mobile systems, then we are using electronic remotes in like using in the TV, then a car, a lot of things. We a lot of places we are using the embedded systems. That all will comes under this IoT things. IoT is an advanced automation and analytics system which deals with artificial intelligence, sensor, network, electronic and cloud messaging. A lot of concepts will be included in these things, and then it will be provided after collecting the data, and analysis also it will done based on the experience. That all will comes under this artificial intelligence concepts. So IoT is always connected with the artificial intelligence and machine learning. So it will be a perfect systems when we are using the thing. Okay. Then our IoT architecture. In the IoT architecture, we're going to see the major four things. One is a network infrastructure. Next one things. Next is a gateway, and final is a cloud infrastructure. Each will be doing a separate works. Then future of IoT. The most important feature of IoT on which it work are connectivity, analyzing, integrating, activity engagement, and many more. Connectivity is comes under the connectivity is referred to establish a proper connection between all the things like a sensor devices, then platforms, and wherever we are using a multiple sensors, all those things, gateways, cloud, all those this connectivity will be comes under this connectivity part. After connecting the IoT devices, it need a high speed messaging between the devices and cloud enabled, reliable, and securable and bidirectional communications. That's why we are taking is the connectivity is more important in this IoT devices things. Next one is analyzing. After connecting all the relevant things like a sensors, then it comes to real-time analyzing the data collected, because the sensor is collecting the data and sending to the cloud. So that cloud data will be analyzed. Use of this cloud data, we are going to build a business intelligent model. Based on this model, we're going to take a decisions. Then the future of IoT is in various places we can able to use like a security things, integration, then activity engagement, automation, endpoint management, connecting, scaling, sensing, analyzing, and artificial intelligence. A lot of features we can able to use it. This integration thing is IoT integrated with the various module to improve the user experience as well. Then artificial intelligence. We all know about the artificial intelligence is nowadays playing a vital role in this technology world. That thing is an IoT is make a things smart and then enhancing a life through the use of data. For example, if we have a coffee machine who's been having going to end, and then coffee machine itself order the coffee beans of your choice from retailer. So because of that will be based on the experience, the machine will take a decision and then it will provide it whatever easy to us that will be changing our life, enhancing lives. Then sensing. Sensing is the sensor devices are used for sensing their activities. IoT technologies detected and measure any changes in the environment and report on their status. IoT technologies bringing the passive network to active network. So without the sensor, there is a could not connect hold the devices through the IoT information. Then active engagement. IoT make a connected technology, product or service to active engagement between each other. The endpoint management. It is important to be an endpoint management of all the IoT systems. Otherwise, it makes a complete failure of the systems. So now we go into the thing of physical design of IoT. The physical design of an IoT system is referred to the things, device, and protocol that used to build and IoT systems. All these things like sensors, routers, whatever things we are using devices are called node devices. And then every device has a unique identity for identifying any difficulties are there, any data is not received like that. That perform remote sensing, actuating, and monitoring work. Then the connectivities we are using wired or it may be wireless cables, wireless things we are using. Then processor. A processor is like a CPU that other units are used to process the data. These data are further used to improve the decision quality of an IoT devices. So these things we are going to represent as the pictorial format. Like connectivities, we may use USB cable or that may be an Ethernet things. Then processor is a CPU, like we all know about it. Then the graphics is a CGPU. Then audio. Some of sensor will be sensing the audio signals, and then some of things will be going to sensing the picture thing. So that is a video signals. So we have to use an audio video interfaces. Then storage interfaces. The storage concept. We may store internal or we may store in the cloud. So if we are going with the cloud, we have a different part that we have to need an internet connectivities. If we are only storing the data internal, so we need a SSD card or it may be an any memory unit devices we need to connecting. Then IoT interfaces. This thing is we going to connect the sensors, actuators, and the routers. So that we need to IoT devices. Next one, we are taking some example in various places like medical industries, medical care premises, like an elder homes, or it may be in hospitals. We can using the nowadays we are using the IoT devices like a patient regular monitoring by using the IoT devices that will be managing, that will be checking the blood pressure of the patients, then body position if it may be changes or it may be like that, then ECG, then airflow sensors, then EMGs, then body temperatures, then glucose sensors. Now we're going to see the medical premises in the elder homes. There will be we are using a lot of IoT devices in the medical units like we're going to use body position sensors and ECG, airflow sensors, and body temperature sensors, then blood pressure, glucose sensors. This all will be connected in the method of sensors. Then the doctor is minimal needed at the patient place. They can able to monitor it anywhere else because we can connecting in the local gateway to the wider end, that is a mobile monitoring devices we can able to use. We are storing this data frequently. It will be monitoring, that will be stored each and every time, that will be monitored and that will be stored into the cloud. So doctor can check wherever he is there. They can able to check in the remote and they can take a decisions also there. Then audio video interfaces we are using for the sound, any noise is happening or any movement is there, we can able to record it. Then input output interfaces, we are all those things we are using. Now we're going to see the protocols in the IoT devices. Internet protocol, smart object protocol we are using for this IoT things. That's an application layer. We all know about the OSI layer. Same thing we going to here, but it will be composed of the things like linked layer, then network layer, transport layer, then application. These 4 layers we are using in the IoT devices things. So this linked layer we are using a Ethernet, IEEE format and the wireless, or maybe we can able to use it. Then network layer deals with an IPv4 or IPv6 model. Then transport layer we comes into the TCP UDP. Then HTTP or for the application layer. But when we are coming into the IoT devices, we are using few things like the link layer. Link layer, in this link layer, we are using local or metro networks. But because of we are using the cloud concept. That's the thing. Then network layer. So see here we are using a WAN. Then transport layer we are using a user datagram protocol, like a UDP protocol we are using. Then POP it will be used for an application layer. Next one is application. We're going to see briefly about the application layer protocol. Here in this layer protocol define how the data can be sent over the network with lower layer protocol using the application interfaces. So we all know about the HTTP that will be transferring the hypertext. Then WebSocket, this protocol enable two-way communication between the client and the host. So we are using the sensor. The sensor will sending the data to the cloud. That cloud will be receive the signal. After that will be sending the return data. Then transport layer. Transport layer is we are using in the IoT devices a UDP, a user datagram protocol. It's a part of internet protocol and called a connectionless protocol. This protocol is not required to establish the connection to transfer the data. For example, if we are the sensor is sensing the data, it's not needed to connect it again and again. It will just sending the data to the cloud. After that cloud data received, then it will be sending any acknowledgement. If we want to take some decision based on the data received, then it will be sending as a signal. So in this thing UDP, we are not required any establishment in the connection between the device sensor and then cloud. Next one is a network layer. We are using IPv4 or IPv6. So these two type of model we are using for the network layer. Then link layer, it's an Ethernet. We all know about the Ethernet and Wi-Fi things, because when we are using a wired, we will using a Ethernet. When we are using the wireless, we are using the Wi-Fi models. Logical design of IoT. Here in this logical design, we are having the major 3 things. One is a IoT functional block, IoT communication model, then IoT communication API. Here first we are going to see the IoT logical designs. Here we are using the application, service, communication, device, then security and then management. So when we are coming into the IoT functional block, there is a device. What are the devices we are using for like a sensor, actuator, monitoring, control functions, any device, whatever things we are using in the IoT thing, that will become under the device. Then communication, handle the communication for the IoT systems. Then services for device monitoring, device control the services, data publish the services and service for device discovery. Then management. So this block provides various functions to govern the IoT systems. Then security things. Security, this block secure the IoT systems. Wherever we are using the IoT systems, we have to secure the things that, and by providing the functions such as authentication, authorization, message and content integration and data security. Next one is application. This is an interface that the user can use to control and monitor the various aspects of the IoT systems. So whatever the applications we are using in the IoT devices, that will all come under the application part. Then IoT communication models, we are using the request. 4 models we are using the thing. One is a request response, second one is a publish and subscribe model, third one is a push pull model, then fourth one is an exclusive pair model. Here request response model is a communication model in which client sending the request to the server, then server respond to the request. So that is the thing, is the same as whatever the clients or server devices we are using, same model it will be working. The request response is a stateless communication model and each request response pair is independent of other. Then HTTP work as a request response protocol between client and server. A web browser may be the client and an application on computer that hosts a web site may be a server. In the client server model we can able to know about it. The resource will be available with the server. Then client needed that resources. So client is asking the request to the server. Server receive the request and checking the client is whether they are authenticated people or not. Then it will sending that resources to the client. That is the thing, is the request response model. Then publish subscribe model. The publish subscribe model is a communication model that involves publisher, broker and consumer. Like, and we going to publish and then that will be published in the internet or in intranet. We can subscribe, then we can able to use it. So in between some of broker will be happening, like a YouTube we are using, like that is that things we can able to use it. So publisher or source data. Publisher sends a data to the topic which are managed by the broker. Publisher are not aware about consumer. Consumer anybody will be there. Like for example, we are using the Google Maps. Google Maps any people we can able to use. So the consumer is the people. The sensor will be sensing the places and sending the data to the Google Cloud. So that Google Cloud is a broker. So the data is publisher. The sensing the things that will be sending to the broker. Then consumer anybody can able to use it in this model. So the publisher normally sending the topics about that what they are recognized, and that will be sending to the broker. Broker will store the data based on the topic, whatever things like that. Then subscriber will subscribe the data and based on that thing they can able to watch the topics. Then IoT communication API. Generally 2 API for IoT communication. First one is a REST based API. Second one is a WebSocket based API. So REST based communication, it follow the request response model communication and apply to component connector and data elements. So then the WebSocket based communication, bidirectional communication between the client and server. So we're going to briefly see about the REST based communication API. Representational state transfer, that is an REST expansion, is set of architectural principle by we can design web service, the web API that focus on the system resource and how the resource states are addressed and transferred. So REST API that follow the request of the communication model and the REST architecture constraint applied to the component, connector and data element within the distributed hypermedia systems. REST API we can able to use in the any type of phones like in a mobile apps like that. We can browse the data and we can transfer the data to the server cloud things. Then client server model. The client server principle behind the client server constraint in the separation of concern. So for example, client should not be concerned with the storage of the data, which is concern of the service. So they need a server, they need a data, that's all. So the server is bothered about the server, whatever things, they will be stored the data. Then stateless, each request for the client to the server must contain all the information necessary to understand the request and cannot take advantage of any stored context on the server. This session state is kept entirely on the client. Next one is a WebSocket based communication. WebSocket API allow bidirectional full duplex communication between client and server. WebSocket API follow the exclusive pair of communication model. Unlike request response models such as REST, the WebSocket allow full duplex communication and do not require new connection to be set up for each message to be sent. So the WebSocket communication begin with the connection setup request sent by the client to the server. So we can, once we are set up the connections, that will be permanent for any time we can able to send the data. So first of all, we need to establish the connection. So client is sending a request to the WebSocket portal. So server will receive the data and sending the response of accepted the request. So now that connection is established. So then after that, it is like a handshaking concept. So after that, handshaking by through the HTTP. Then after that, we are going to sending the data to the client to the server. Server will respond the data in the bidirectional way. So that will sending and receiving will continues till that whatever time we needed. If we want to close the connection, so client will sending the closing connection close request to the server. Server is receive that request and after that it will check what is the information they are given. So it's a request for the closing, then it will be request is accepted, the connection is closed. Then IoT enabled technologies. So this IoT enabled technologies we are used in various places. So this major thing is wireless sensor networks we are using for the concept of weather monitoring systems, indoor air quality monitoring systems, then soil moisture monitoring system, surveillance system, structural health monitoring system. In various places we are using the wireless sensors that all will come under the IoT enabled technologies. Like then the cloud computing. Cloud computing is one of the area which is we have to managing the data in the cloud. So in this concept also, IoT devices also we are using the cloud concept. How we are using? Just we are getting the data from the various sensors. A lot of numerous data will be coming from the sensors that will stored into the cloud because we are unable to manage a lot of huge data. So we can buy the cloud account. We can transferring the data, sensed data to the cloud. Once data is transferred to the cloud, we can able to get it from anywhere else because it will be stored in the cloud. So we need to access only the cloud accessing things. So cloud computing resources can be accessed over the internet using the standard access machines. They can able to check, they can able to monitor and how it will be work. This is the thing is a pay as you go. So that will be used for the IoT concept in the cloud computing concepts. Then when we are coming into the cloud, we are having a lot of various places we are using nowadays. Then infrastructure as a service, then platform as a service, software as a service. When we are coming into the IoT concept, we need an infrastructure. Okay, because we need a server is needed things. That is the thing. Then if you want to take some more decisions making thing, we need a software as a service. Then big data analytics. Big data analytics is a major role player in the IoT devices because we are connecting a lot of IoT devices which is transferring the signals. So based on the signals, it will be giving a numerous data. Like if for example, we are collecting the data for each seconds, one data. So it will 1 hour, it comes into the huge data. If we are taking one day, it's numerous data. We are going to take a month. So that time we know about it, it's a huge data. So based on the data, we have to take a decision. How we can able to take by using this big data analytics. So these all will be completed in the area of the cloud. Based on that analysis, we have to take a decision. That decision we have to give to the sensors. I mean, we are going to take a decision. The software will take a decision. And what is the thing that sensor have to do after this type of activities? Then that will be giving as a signal to the sensors. So sensors is sensing the data and transferring to the cloud. Cloud will be receiving the data and store the data, and the big data will come under for the analytical part, and they can take decisions. Then IoT levels and deployment template. This is important of the IoT devices connectivity. So in the IoT levels, we are majorly using 6 levels. But basically, we need to know about few things like a device. So what is a device? Like a sensor, software, computer devices, internet, wired, actuator. So any device we are using, that will come under the device concept. Then resources. There is a software component on the IoT devices for accessing, processing, storing sensor information, and controlling the actuator, connector devices. Then battery, UPS, and everything will come under the resources. Then the control service, a native service of that runs on the device and work between the node device and web service. Control service sends the data from the device to the web service and receive the commands from the applications via web service for controlling the devices. So then the database, that will be as a storage concept that will be stored the data it's created in the sensors. Then web services, we are know about the web service we are using for the applications. Then analysis components for the huge number of data, will be analysis and taking decisions for we're going to do the next step. Then applications, IoT application provide an interface that user can use, control and monitor various aspects of IoT systems. Then the first level of IoT. First level is a basic levels. In this IoT level 1, the system has a single node devices, a single sensor devices, perform and sensing the data and store the data and then perform the analysis in the host area. So it's a huge, it's not a huge area, it's a small area like a home. We are using IoT device, we are using the mobile, so same like that. So in this, it's suitable for modeling a low cost, low complexity solution where the data involved in not a big, it's new minimum data. Like for example, we know about it, we are using mobile systems. In this mobile, automatic brightness will be there. So based on the lighting in the surround, automatically the brightness will be increased or decreased. So this is a device for the IoT level 1 example. So in this IoT level 1, we are using the areas like an applications, like how it will be checking. Then the sensors will be there, sensor will be sensing the data. Then that will be sending to the database whether it is, how much of brightness will be there. Now light is 100%. So no need of brightness, so it will be, brightness will be reduced. If there is more dark, then we need more lighting, so automatically our mobile is boomed and then it will be coming into the brighter concept. So that is a thing, is a basic example for the IoT level 1. Next one is a IoT level 2. It has a single node that perform sensing and or acquisition and the local analysis will be done. So in this IoT level, database and application established in the cloud. So in this, normally when we are coming into the mobile, we are taking a mobile. In this mobile, the data will be sensed in the local, analysis also done in the local, and take a decision in the local, and it will be start the processing on it. But when we are into the IoT level 2, the data is sensed here and sending to the cloud database. So the database is stored in the cloud. Based on the cloud, we can able to take a decisions. So normally the IoT level 2, it will becomes for the lot of node devices will be available in the local, but the data is transferring to the REST or WebSocket communication, and it may be in a wired or Ethernet concept. We are connecting to the database. So that database will be receiving the data and storing into the cloud. So we can able to see what is the data is received by using the applications. But in this difference between the IoT level 1 and IoT level 2, the data is stored in the cloud, that is comes under the level 2. Its data is in the local, that will be comes under the level 1. Then next one we are going to see the IoT level 2, 3. So in this thing, it has a single node, the database in application establishment in the cloud. It's a suitable solution for the way the data involved a big and analysis is required computationally intensive. So like when we are needed analysis part, if we are having a more data received by the sensor, so that time we going to using this level 3. In this level, the data will be received from the sensors through locally. After that, it will receive and is transferring to the control service of that area's hub or like a routers. It will sending to the connectivity cloud. That will be the database will be available in the cloud. After that, receiving the data, that huge data will be analyzed. So the cloud area, the analysis will be done, and it will be we can able to view through the applications. That is a level 3. So IoT level 2, it will receive a data and store into the cloud. We can able to see the data. But when we are coming into the IoT level 3, the data will be analyzed. For the data is previously collected the sensor, no? That huge data will be analyzed. Then next one, it comes under the IoT level 4. It is a multiple node that perform local analysis. It is a cloud-based application and database. These IoT systems contain local and cloud-based observer node. It's a different here. Observer node, which can subscribe and to receive information collected in the cloud from IoT node devices. It is suitable for solution where we are using a multiple nodes. Now we are coming with the multiple sensors. That's a multiple node. And the data involved is a big, and the analysis is required computationally intensive. So a huge number of devices will be connected in the local areas that will receiving the data, that will all transferring to the REST service, and then observer node will be performed in the cloud. Then after that, data will be stored in this cloud, that will be analyzed. After the analysis, it will sending to the application. So this is a part which we are having the observer node in the cloud area, and even though we are having the observer in the local area also. Next one is IoT level 5. It has a multiple end nodes. So multiple sensors we are having. Then one coordinator node will be there. That end node used for sensing and actuation. So that means sensor will sensing the data and transferring to the signals. In this model, coordinator node collect the data from the sensors and transfer it to the cloud. In this model, we use cloud-based database for store and analysis data. It's suitable solution for based on the wireless sensor network, in which the data involved is big and the analysis requirements are computationally intensive. So we need to analyze the data which is stored in the cloud. Then that's IoT level. The major area in the local part is we are using a lot of endpoints, lot of sensor devices will be there that will try receiving the data, sensing the data and sending to the observer node. That observer node will transferring to the REST APIs. Then it will store into the cloud concept. Then cloud concept will be receive the data and then stored, and then finally it will be analyzed. based on the whatever intelligence we can able to do, that will be done there. After that thing, the cloud, coordinator, we are already told about that level 5. We are having a lot of endpoints, then coordinator, then cloud analysis. So like a endpoint will sensing the data and sending to the coordinator node. That coordinator will transferring to the cloud, then cloud there will be analysis work will be done. So this is the thing in the IoT level 4, 5. Then now IoT level 6, this is a final level, it's a highest level. It has multiple independent end nodes. We have to see here multiple independent end nodes that used for sensing or reputation and transfer data to the cloud. We used cloud-based database. So the database will be there in the cloud. Multiple end nodes will be available in the local areas. Then the analytics component analyze the data and store the result to the cloud database, and result are visualized with the cloud-based application. So that means the data is sensing by the nodes, then the data will be transferring to the cloud. After the cloud, it will receive the data and analyze the based on the analysis results. It will be visualized what we going to take now. What is the decision we have to take now? That is the thing will be in the IoT level 6. Here we are using the same whatever things in the IoT level 6, that will be also here same we going to use, but the next step is we going to here centralized controller will be there. The same observer node will be there, same the multiple devices we are using, then analysis we are using, the cloud storage will be there, then all the applications we can able to see here. But in this thing, we going to use a centralized controller for multiple devices, because each devices are independent devices. There is no dependent devices. So when we are coming into the independent devices, we need a centralized controller for controlling all those nodes and all those sensors. So it will take on a part, that is a thing, centralized controller. That will centralized controller will be available in the cloud areas. So that will receive all the data from independent modules. Then it will store into the cloud based on the thing. Analysis will be there. As a good example is a Google Map. If we are checking, if we are moving one place to one place, so that time we can able to check it which area now traffic, which area is best to moving easy, which route is easy to reach the destination. We can able to finalize by using all will comes under this the IoT things. For example, if we are sensing that there will be a huge traffic in area, in for specific areas, then when we are opening that Google Map, we can able to see the things. Multiple sensors will be there in the each signals. So that signal will be sensing the data. There will be a huge number of traffic, number of vehicle will be there, huge number of vehicle will be there. Already there will be a more traffic. So that each area devices will sending the data to the cloud. That is a Google Cloud. So that Google Cloud receive the data and the data will be analyzed. After the things, what will happen? Then that signal will be received and then it will be going into the Google Map server applications. We are seeing the application. Which route is shortest route? We can able to know. And which route have more traffic? We can able to know. Which route is best for car? Which route is best for cycle? Which route is best for train? Everything we can able to check it. That things is comes under the IoT things. So this is all comes under the IoT basic things for our knowledge. Thank you.